purpose of this video today is to show the proper way to use one of these non-contact infrared thermometers when monitoring the heat while straightening aluminum panels. I see a lot of misinformation within the industry regarding the proper way to use these, so let's find out today how that's done. All objects have what we call an emissivity rating. Emissivity is the object's ability to emit infrared energy, and the amount of infrared energy emitted is tied directly to the temperature of the object. Emissivity ratings can be anywhere from 0, which is a completely reflective surface like a mirror, up to 1, which is a completely flat surface like a car tire or asphalt. Most painted, organic or oxidized surfaces have an emissivity rating of close to 0.95. Therefore, these types of infrared thermometers are calibrated to read properly at an object has an emissivity rating of 0.95. Shiny, bare aluminum is way more reflective than that and has an emissivity rating much lower than 0.95, and therefore if you use these on bare aluminum or bare metal surfaces, you get an inaccurate reading. It will actually read much lower than the actual temperature of the object. So let's do a demonstration that shows this. So what we're going to do is take a 1mm 60-61 aluminum coupon. We've put a piece of tape across the top of it, scuffed the middle of it with a Scotch-Brite disc on a small grinder, and left the bottom untouched. I'm going to use a MAP gas torch and apply heat on the bottom area where it was untouched while we monitor the temperature on the tape. The tape should pick up the actual temperature of the aluminum because it is stuck tightly to it. Once we get this up over 400 degrees somewhere, I'm going to pull the torch away. We're going to drop the infrared thermometer down to the bare aluminum that we have not sanded. See what happens to the temperature. Then go up to the area that we've scuffed, see what we get there. Now the aluminum should, if anything, actually be hotter in this area where the torch was being applied. But let's see what kind of readings we get when we try to take a measurement using a non-contact infrared thermometer on bare aluminum and on scuffed bare aluminum compared to the tape. The taped area is going to have an emissivity rating close to the 0.95 that the thermometer is calibrated for. The other areas are going to have varying emissivity ratings dependent upon the reflectiveness of the surface. So here we are, we're about 14 inches away, like I said. We're getting up over 300 degrees now. Here we're over 400. So on the tape we're getting readings in the 400 to 425 degree range. We go to the scuffed surface, we drop down to the 225, 230. On the unscuffed surface, right where we had the heat, we're down under 200. Scuffed surface, we're back up over 200, and on the tape, we're back up over 400 again. So as you can see, we're ready to use one of these thermometers on a scuffed surface that I had ground off to straighten. I'm going to get a very inaccurate reading. I'm going to be overheating the aluminum probably to the point that I have actually annealed it and permanently softened and ruined the panel that I was working on. So be sure if you're using one of these, put a piece of tape close to where you're heating. Monitor the temperature on the tape, which will give you a much more accurate reading than you will get off of the bare and reflective aluminum surfaces that you have ground on or on any unground surfaces. You will also, if you're monitoring on a painted surface, get a much clearer and more accurate temperature off of the paint. Even though it is shiny, it doesn't have the same reflectiveness for the infrared that the bare metal surfaces do. So monitor on tape, monitor on painted surfaces. Do not monitor with an infrared non-contact thermometer on bare aluminum or steel. As with all equipment, be sure to read the user manual that comes with it. The user manual for this thermometer explains the emissivity effect and gives you instructions for how far to be away from the object being measured to ensure accurate measurements are taken.